Children, today we will start our discussion from paragraph number 5.5, Dalton Law of Partial Pressure. So first thing is, what is the meaning of partial pressure of a gas? In the mixture condition, when more than two different non-reacting gases are kept together in a particular vessel, then the pressure exerted by a particular gas on the wall of the vessel is known as its partial pressure. Okay, so with the help of this Dalton's law of partial pressure, we can determine the partial pressure of a particular gas. Okay, so according to the definition of the Dalton's law, at constant temperature, the total pressure exerted by a mixture of two or more non-reacting gases enclosed in a definite volume is equal to the sum of all the partial pressures that each gas would exert if it occupies the same volume alone. Okay, so it means if more than one gases, we are having three different gases A, B and C, and which are kept in a vessel of volume V. Okay, so all the vessel with same volume V and three different non-reacting gases A, B and C are kept individually in a vessel. Let in this individual condition, gas A is exerting pressure PA on the wall of the container. Same way, gas B is exerting PB pressure on the wall of the vessel or container. C is exerting PC pressure on the wall of this container. Okay, then we are having one more vessel V, and in this vessel we mixed all these three gases together. Okay, A, B and C are mixed here. So let in the mixture condition, the volume V vessel is having pressure P total. So according to Dalton's law of partial pressure, the P total will be equals to the PA plus PB plus PC, and these are the partial pressure of the gases which are kept here in this mixture condition here. Okay, so as I told you already, that pressure exerted by an individual gas is called the partial pressure. And if partial pressure of individual gases, here it is given as in the terms of P1, P2 and P3, then the P total will be equals to the sum of the partial pressure of different gases P1 plus P2 plus P3. The next heading is utility of Dalton's law, or importance of Dalton's law, or you can say use of Dalton's law. The first point, determination of partial pressure of dry gas. So most of the time what happen, we collect a particular gas over water, and in this condition the gas which is collected will be a wet gas, and in wet condition the pressure of wet gas will be equals to pressure of dry gas plus pressure of water vapor. Okay students, so if we want to calculate pressure of dry gas, then we will change this relation. Means pressure of wet gas minus pressure of water vapor will be equals to pressure of dry gas. So in this way we can calculate pressure of a dry gas with the help of water vapor pressure and pressure of the wet gas. Second point, in the calculation of partial pressure of the gas. So if partial pressure of different gases are P1, P2 and P3 respectively, then with the help of ideal gas equation, we can find out P1 as N1 RT upon V, and P2 as N2 RT upon V, and P3 as N3 RT upon V, where R is universal gas constant, T is temperature in Kelvin, and V is the volume of the vessel in which these all P1, P2, P3 are contained in mixture condition. Okay. Now, according to Dalton's law, the total pressure of the mixture of gases will be equals to the total sum of partial pressure of different gases. Means P total will be equals to P1 plus P2 plus P3. Okay. Now, when we will put the value of P1 and P total in the terms of N, RT and V, then as you can see here, the P1 will be equals to N1 RT upon V, and P total is equals to RT N1 plus N2 plus N3 upon V. So putting these values here in the relation of P1 upon P total, we will get P1 upon P total will be equals to N1 RT upon V into V upon N1, N2, N3 RT. Okay. Again P1 upon P total, P1 upon P total. So these will be get cancelled. So we will get N1 upon N1 plus N2 plus N3. And we know that this ratio is known as mole fraction, because here N1 is present here. So this is the mole fraction of the first gas, which we will be represent as X1 or Chi1. So P1 upon P total will be equals to Chi1. Okay. So same way we can calculate for the other gases also. X2 will be this and X3 will be this. So from this relation, P1 upon P total equals to X1, we can simplify it as P1 equals to P total into X1. Okay. So according to this relation, the partial pressure of the first gas will be equals to total pressure into its mole fraction in gaseous state. Okay. Same way, partial pressure of the second gas will be equals to P total into mole fraction of that gas in gaseous state. Okay. So in this way, we can calculate partial pressure of a particular gas which is present in a mixture condition, showing P total pressure and its mole fraction is X1, or mole fraction is known. Okay. So with the help of total pressure and mole fraction of a particular gas, we can calculate its partial pressure. Next is Graham's law of diffusion. Now first, what is the meaning of diffusion? Simply you can say that movement of solvent or solute particles from their higher concentration site towards lower concentration site is known as diffusion. Okay students, for example, as given here, if you are having two gas jars which are filled with hydrogen gas and bromine vapors. So hydrogen gas is a colorless gas, whereas bromine vapor is reddish brown gas, and you inverted gas jar of HCl over the gas jar of bromine vapors, which are separating with each other with the help of disc. Okay. Now if you will remove this disc, then movement of hydrogen gas will start from this jar towards bromine jar, and movement of bromine gas will start from its jar to the jar of hydrogen gas. So this intermixing will start without any external agency, and after some time you will get a mixture of hydrogen and bromine gas in these two jars, which is showing yellowish brown color. Okay, so according to the definition of diffusion which is given here, diffusion is the intermixing of two or more gases irrespective of their density and without the help of any external agency. Okay, so irrespective of their density and without help of any external agency means diffusion is an autonomous process. Okay, and any heavy gas can be mixed with lighter gas, or lighter gas can be mixed with heavy gas. No any effect of density is there. Okay, students. Now one experiment is given here. According to this experiment, one porous pot is there which is filled with air, and this porous pot which is filled with air is having a cork which is fitted with a U-shaped tube, and this U-shaped tube is having colored water here in this bulb. Okay, now passing hydrogen gas from here, we know that hydrogen is lighter than air, so hydrogen will diffuse inside this porous pot comparatively with high speed, and air will come out from this porous pot to outside comparatively with lower speed. Okay, means a pressure will be formed inside this porous pot, and due to this pressure, the pressure will be exerted on this colored water, and this colored water will rise up here in this U tube, in this limb which is having a jet. So this colored water will come out through this jet in the form of fountain. Okay, students, so this will happen there due to the higher pressure inside the porous pot. Okay, now when you will stop this sending of hydrogen gas inside, then the pressure inside the porous pot will get lowered, and that is why the water, colored water which will present here will come again to this part. Okay, and bulb will refilled again. Okay, so after stopping this hydrogen gas here, you will find that the level of colored water will start rising here in this bulb. Okay, so according to Graham's law of diffusion, under identical conditions of temperature and pressure, the rates of diffusion of gases are inversely proportional to the square roots of their densities or molecular masses. So, in the mathematical terms, R is proportional to under root 1 by D, where R is rate of diffusion of a gas and D is its density. If we are having two different gases which are having a rate of diffusion as R1 and R2, so R1 will be proportional to under root 1 upon D1 and R2 will be proportional to under root 1 upon D2, where D1 and D2 are the densities of different gases 1 and 2, and R1 and R2 are the rate of diffusion. After combining these two relations, we will get R1 upon R2 equals to under root D2 upon D1. Okay, and we all know that density is proportional to molecular mass. So we can write the same relation in extended form as R1 upon R2 equals to under root D2 upon D1 equals to under root M2 upon M1. Okay, students. So this is the relation which we used most of the time. Now we can modify this relation in other terms also. So if we are having two different gases with same volume V, and these gases are diffused in different time t1 and t2 respectively, having a rate of diffusion as R1 and R2, then from equation 5 and 6 we will get R1 upon R2 equals to V upon T1 into T2 upon V. Because V and V are same, so these will be cancelled out. So overall relation become R1 upon R2 equals to T2 upon T1. And finally we will get this relation where rate of diffusion is proportional to T2 upon T1, means rate of diffusion of gas 1 is inversely proportional to its diffusion time, or you can say that rate of time for the diffusion of a particular gas is directly proportional to its molecular mass or its density. Okay, so here written also, time taken for the diffusion of equal volumes of the two gases under identical conditions of temperature and pressure is directly proportional to the square root of their densities or molecular masses. Then if different volumes of the gases get diffused in a particular time t, same time t, then the relation we will use this relation where R1 upon R2 equals to V1 upon V2 equals to under root D2 upon D1 equals to under root M2 upon M1. Okay, students, and we know that rate of diffusion we can write in different terms. So according to the terms which we are going to use for the rate of diffusion, we will modify the relation also which we are going to use for rate of diffusion. Okay, and if different masses are given, then we will use this relation for the rate of diffusion of the gases. If different pressure are given, then we will use this relation. Then effusion. We know that intermixing of two gases is known as diffusion, whereas when a gas is allowed to escape through a tiny hole is known as effusion.